So to start with, you need to know these things, which hopefully you already know from earlier this year and last year. X to the 1/2 is the same as the square root of x. Yeah? X to the 1/3 is the same as the cubed root of x. To the 1/4, 4th root of x, 1/5, 5th root of x, etc., etc. If we have x to the 2/3, for example, that's the same as x to the power of 2 times a third. Right? 2 times a third is just 2/3, which you can then write as x squared to the power of a third. Or if you do a third times 2, then it could also be x to the 1/3 to the 2. Right, this is all just 2 times a third equals 2/3. So this one here can become x squared, and then take that to the cubed root. And then this one here, you can do the cubed root of x to the power of 2. So you can write it either way. So that was all coming from this one here. You can write it either that way or you can write it that way. So just remember, your denominator number is the root number and the numerator is the power. Okay, so fractional powers, again, work exactly the same as our normal polynomial derivatives. So if f of x equals ax to the n, then f dash x, the derivative, is equal to, take the n down, multiply it, minus 1 from the power. Right, same as what we've been doing this whole time. Right, so 3x to the power of 1/2, find the derivative. So if our question's just given to us in that form, what's the notation for the derivative? D dx, yep. Right, bring the power down, multiply it, minus 1 from the power. So we bring half down and multiply it, what do we get? 3/2, yep. X, and then a half minus 1 is? Negative half. Good. What does negative power mean? Yeah, it goes under 1 over x to the half. Right, so x to the negative half is 1 over x to the half. X to the half is? Yep. And multiply those fractions, you get 3/2 square root x. Of course, you can leave it looking like that, but if you want to fully simplify, then that's also correct. Would you ask to fully simplify? Yeah, probably. But it depends on the question. Like if you want to go ahead and do more working out with it, it's probably easier if it's in that final form. Because having negative powers kind of makes it a bit complicated. Okay, another one. X to the 1/5 minus 2x to the negative 3? What's the derivative?
DDX.
Yeah, ddx, good. Okay, we'll do the first term. So what's the derivative of x to the 1/5? 1 on 5, x to what? Yep. Yeah, just 1/5 minus 1. Minus 1 from the power, always. Yep. Okay, negative 2x to the negative 3. Yeah. Minus 4. Good. Now, simplify. 1/5 times x to the negative 4/5 is 1 over x to the 4/5 plus 6 x to the negative 4 is 1 over x to the 4. Might be easier if we include a few brackets just so we don't get mixed up with our BODMAS. Okay, what is x to the 4/5?
4 root, no, 5 root 3.
Yes. Good. Again, doesn't matter if the 4 is inside the root or outside, means the same thing. Plus 6, or we can multiply that one straight over. So 6 on top, x to the 4 on bottom. Okay, so then we just got to multiply that first fraction out. So we get 1 on the top, 5/5 root of x to the 4 plus 6 on x to the 4. Probably just leave it like that.
Okay.
Yeah, they'll be far too hard to try and simplify that into one fraction. So just leave it like that. Next one, which is slightly harder. 2 square root x, x squared plus 2. Now, in this one, we've actually got two functions which are being multiplied together. We've got 2 square root x and x squared plus 2. It's actually going to use what we call the product rule, but we'll learn that next lesson. So for now, what you're going to do is just expand out that bracket. Now, is it easy to expand out when you've got a square root x? No. So what will you change the square root x to? Yeah. Right, and expanding out, you've got 2x to the half times by x squared. So when you're multiplying unknowns with a power, what do you do to the powers? Add them. Yeah. So half plus 2 is 2.5, which is 5 on 2. 2x to the half times by 2, 4x to the half. Right, so now we need to do the derivative. Oh, yeah, so ddx. Right, take the 5 halves down, multiply it by 2. What do you get? 5 halves times by 2, 5. Yeah. Times by 2, you get 10 halves, which is 5. So 5x, 5 on 2 minus 1. So 2.5 minus 1, 3 on 2. Yeah. Yep, okay, so the derivative of the second term. Yes. Very good. Okay, what is this term? 5 times what?
X to the 3 root x squared.
The denominator is the root
It's
number. Right?
Why don't you put the 2 in the front first? Yeah, that's fine. That's a regular square root.
Because it's just a regular square root.
Makes sense.
Yeah. I mean, you can, but that means the same thing.
Okay.
You don't need the 2 because the square root is just the 2 square root. Yeah. Right. The second term is 2 times 1 over x to the half because it's a negative. Yes.
With 5 times x
Mm-hmm.
squared 5. It doesn't matter if it's in or out.
The 3 doesn't matter if it's inside the root or outside. You can do it either way. Yeah, so this one is just 5 root x to the 3. And this one is, multiply the 2 on top. X to the half is square root x. Now, this is fine. You can leave it like this. However, we can go one step further. Yes, Johnny?
So if we didn't put it square root x and just have the x to the power of a half,
That would be fine. I'd still accept it. But you know, we're just simplifying and playing around with it. Do you want to try and simplify it into one fraction?
Not really.
Yeah.
Why not? Why? No, you probably could leave it like that. But you know, not everything is just. Don't just learn it because it's going to be on the test. Learn it for fun. Okay, what do we need to be able to add 2 fractions together?
Denominator?
Yep. So we're going to do that one on top. We have to multiply it by the same thing on the top and the bottom. Right? So we've got square root x cubed times another square root x. How many square root x's is that?
4.
To the 4. So we get 5 square root x to the 4 plus 2 all over square root x. Okay. Square root x to the 4 we can actually simplify because square root x to the 4 is the same as square root x squared squared.
X squared.
Because this squared and this square root cancel each other out. So we get 5x squared plus 2 over root x.
Why doesn't that work with 3?
With a what? With a 3?
Yeah.
Because you'd get, because this would just be like root x to the 1 times 3. Or you could do it like this, which
X, because it's root x times root x.
oh yeah.
What?
So you could do root x times root x times root x. So if you did that one, that would be root x squared. So then that would leave you with x root x.
Sorry?
Because the square root of x squared is x, so you still have x root x. So yeah, this is equal to that.
Nice.
If you wanted to.
Is that simple to work with?
No. But yeah, like what I said, this one over here with the green tick, that is correct. You could stop there. There's no need to really go any further unless the question specifically says answer it over a common denominator or something like that. Yeah, you could just leave it there.